Soviets launch an attack against the United States, the first thing we're going to want to do is to counter that ongoing attack, which will be their ICBM silos. We have to have in this country a penetrating bomber today. I could not stand in front of you and tell you I could carry out my mission if I didn't have a penetrating bomber today. This is what we see when we look at the Soviet Union and their radar pattern and the associated defenses that go with it. By 1998, from a B-2 or a B-1's perspective, this is what the crew is going to be staring at. This is what a B-2 crew would be staring at. Basically, the B-2 will be able to come into the Soviet Union and go through the Soviet Union without being encountered by any Soviet radar system, and I don't have anything else now or on the horizon that can do that besides the B-2.
Faced with the prospect that American air power could soon become obsolete, 40 years ago, the United States set out to build the most sophisticated flying machine in existence. A bomber so state-of-the-art, it would alter the very nature of warfare. For decades, military planners had recognized the importance of air power. The ability to control the high ground offered a decisive advantage in any conflict. And up until the 1960s, many were confident that American air power was the best in the world. But during the Vietnam War, that belief was shaken to its core, as thousands of U.S. aircraft were lost to enemy fire. At the start of the war, an American airstrike into North Vietnam typically involved a group of 16 or so attack aircraft, protected by 8 escort fighters, and supported by another 10 aircraft to suppress enemy defenses. Together, these aircraft formed a strike package designed to maximize operational effectiveness and minimize losses. For the most part, American air power had to contend with North Vietnamese armed mostly with outdated equipment, including anti-aircraft batteries, some of which dated back to the Second World War, and a ragtag mix of obsolete aircraft. But as the war progressed, the Soviet Union began supplying the North Vietnamese with deadly new weapons, including surface-to-air missiles that could strike aircraft up to 45 kilometers away, and the latest generation of Soviet-built supersonic fighters. It meant, by the end of the war, as many as 36 defensive and support aircraft were needed just to get 8 fighter bombers through enemy lines. Strike packages grew to include chaff bombers in an effort to confuse surface-to-air missiles, along with twice as many escort fighters. But even with all the extra support, the Americans still lost nearly 10,000 aircraft. If a less equipped and often poorly trained North Vietnamese army could inflict such heavy losses, many worried about what a conflict directly with the Soviet Union would look like. Because if American air power was rendered ineffective against advancing Soviet forces, the Cold War would shift dangerously out of balance. By the end of the Vietnam War, American military planners had become increasingly preoccupied with how to keep American air power effective, and grew concerned that it might soon be rendered obsolete. It had long been understood that minimizing detection by the enemy would significantly increase the survivability of combat aircraft. Back in 1959, Lockheed engineers attempted to reduce the radar observability of the A-12 and SR-71 spy planes by designing the aircraft with distinctive shapes to scatter radio waves away from enemy radar receivers. The idea was to reduce the range at which enemy radars could detect the incoming spy planes, giving surface-to-air missile crews less time to respond. But these features weren't really all that effective, and it was the spy plane's incredible speed and altitude that allowed it to avoid enemy threats. In shaping the aircraft to reduce its radar cross-section, Lockheed engineers had the right idea, but lacked the ability to precisely calculate how radar waves reflected off the aircraft. And it would take another decade before engineers would make a breakthrough. In 1977, U.S. President Jimmy Carter was briefed on a highly classified, top-secret defense project that few, even at the highest levels of the Pentagon, were aware existed. engineers at Lockheed had come across little-known research by a Soviet mathematician named Pyotr Ufimtsev that detailed precisely how radio waves reflected off objects. Ufimtsev's research was aimed at making civilian airports safer by identifying misleading radar returns from nearby objects like buildings. Incredibly, no one in the Soviet Union seemed to realize its military potential, and the research was allowed to be published internationally. Lockheed's engineers incorporated Ufimtsev's formulas into sophisticated computer software, replacing the previously tedious trial-and-error process of building scale models. They could now more or less predict radar cross-sections in real time and determine which shapes would be virtually invisible to radar. And the implications were profound. If an aircraft could be designed to evade radar detection and have reduced observability across other spectrums, then it would fundamentally alter the nature of American air power. Stealth aircraft wouldn't need escort fighters, radar jammers, or any other form of airborne support. They could operate independently or in small groups, taking out critical targets before the enemy even knew what hit them. What's more, they could knock out air defenses in advance, clearing the way for more vulnerable aircraft. The world's first operational stealth aircraft would be the F-117 Nighthawk. Developed by Lockheed's secretive Skunk Works division and operated by the United States Air Force, the Nighthawk has an unmistakable silhouette. Its angular shape, made up of simple flat surfaces, gave the fighter-sized aircraft a radar signature no larger than a golf ball. To minimize detection across other spectrums, low observable technologies also concealed the aircraft's visual, acoustic, and infrared signatures. But as the world's first truly stealth aircraft, the F-117 was built with compromises, owing largely to technological limits of the time. The faceted shape and other low observable features restricted aerodynamic and engine performance. The Nighthawk was strictly subsonic. Its unrefueled range was just 1,700 kilometers, and its weapons payload was limited to just 2 bombs, totaling no more than 5,000 pounds. Still, the F-117 was a breakthrough, and stealth offered an enormous strategic advantage. Even before the Nighthawk left the drawing board, a second stealth program was authorized in 1979, a new bomber that would be much larger than the F-117. With an unrefueled range of over 11,000 kilometers and a weapons payload of up to 44,000 pounds, nearly 9 times more than the F-117. And while the F-117 had a planned production run of just 59 aircraft, the Air Force was expecting to build at least 165 of the new, larger stealth bombers. In 1980, defense giants Northrop and Lockheed submitted preliminary designs for the new bomber. Although vaguely similar in appearance, the two companies took fundamentally different approaches. With Lockheed having already won the competition to build the F-117, their design was in many ways a scaled-up Nighthawk, featuring a similarly faceted fuselage that made use of already proven radar-reflecting technologies. Northrop, on the other hand, had a larger and, in many ways, more advanced concept. As a radical, pure flying wing, their entry promised to fly more efficiently, further, and carry greater payload. It also utilized an entirely new method of reducing radar signature called continuous curvature, made possible by advances in computational fluid dynamics. Continuous curvature allowed for an even lower radar signature than faceting and improved aerodynamic efficiency. But Northrop's design would also cost nearly twice as much to develop and build. On the other hand, Lockheed's entry met program requirements, and the company had already proven themselves with the F-117. It meant that Lockheed was widely favored to win. But in 1981, America's defense picture changed dramatically when a new president took office.
It is the Soviet Union that runs against the tide of history by denying human freedom and human dignity to its citizens.
Fiercely anti-communist, Ronald Reagan was determined to push back against Soviet influence, and he'd do it by massively boosting defense spending. It meant that Northrop's more capable but more risky design was selected for development in 1981. The new heavy stealth bomber would be designated as the B-2 Spirit and would form the tip of the spear of America's future bomber force.
Today, in virtually every measure of military power, the Soviet Union enjoys a decided advantage.
The Soviets' intense buildup of nuclear arms began 21 years ago after the Cuban Missile Crisis. It's the arms race, with both sides able to wipe out each other many times over.
In the early 1980s, tensions between the United States and the Soviet Union were at an all-time high, and the threat of a surprise nuclear attack seemed all too real. To prevent a nuclear war, the United States needed to ensure that the Soviets understood that there was no way of launching a surprise nuclear attack without receiving one back. The B-2 would fulfill a role that conventional bombers no longer could, flying into Soviet airspace to go after hardened, bunkered, and mobile targets that could escape conventional ICBMs. Capable of flying at high subsonic speeds, the bomber could be anywhere in the world in less than a day, and could operate from forward air bases or directly from the continental United States. With its large payload, the bomber could be configured for a conventional or nuclear strike. And with its high degree of automation, the B-2 would only need a two-person crew, consisting of a pilot and mission commander. With aerial refueling, they could stay airborne for more than 30 hours. Cruising at high altitude towards the Soviet Union, long-range over-the-horizon radars would have no chance of detecting the incoming bomber. But once inside Soviet airspace, the crew would have to contend with a network of ground control stations, surface-to-air missiles, and the latest generation of interceptors with powerful radars. So they would descend to low altitude, utilizing the B-2's automated terrain-following ability to slip below the range of many ground defenses. Soviet interceptors like the MiG-31, in the off chance they could detect the B-2, would also be forced to descend, where they would struggle to locate the stealth bomber against ground clutter while quickly burning through fuel. Once in striking range, the B-2 could hit up to 16 separate targets with devastating accuracy. But the real power of the B-2 wouldn't lie in its ability to fight a nuclear war. It would be its role in preventing one, by convincing Soviet military planners that a nuclear strike on the United States would always be a losing proposition. The B-2 was to be developed under the highest level of secrecy, but the enormous scale of the project made it difficult to keep under wraps. Thousands of Northrop engineers and personnel from other aerospace firms were involved in the program, all of whom needed special clearance, extensive background checks, and careful observation. Early on in the bomber's development, FBI agents posing as Soviet spies arrested a Northrop engineer who was willing to part with billions of dollars worth of U.S. stealth technology for a mere 25 grand. Luckily for the Americans, stealth technology never made it directly into Soviet hands. Instead, the Soviets relied on other sources of information. Details about the B-2 program continually leaked out to the public in the form of speculative articles, trade journals, and publications. Even a 1988 advertisement from Honda featured a crude, full-scale mock-up of the stealth bomber months before it was officially unveiled to the public. By the CIA's intelligence estimates, the Soviets capitalized on the leaked information to accelerate their own stealth programs. But in reality, the Soviets made little progress, either being unwilling or entirely incapable of matching the scale of the B-2 program and the bleeding-edge technologies involved. Because the B-2 would be the most sophisticated flying machine in existence. To maintain the stability of the bomber's highly unconventional flying wing design, engineers developed a state-of-the-art automated fly-by-wire flight control system. To further lower the aircraft's radar signature in combat, the bomber would also feature a highly novel differential thrust system in place of conventional control surfaces. Much of the aircraft would have to be built from advanced composite materials, which meant having to invent entirely new methods of fabrication and assembly. New radar-absorbing materials, including highly delicate coatings, would also dramatically increase the cost of maintenance. The B-2 would have to be housed in specially designed air-conditioned and humidity-controlled hangars. To create the most seamless stealth geometry possible, engineers did away with the gaps, screws, and joints typically found on other aircraft and eliminated almost every service and access panel. So new maintenance procedures would need to be developed just to keep B-2s operational. And if engineering such a novel aircraft wasn't challenging enough, midway through development, the Air Force decided to shift the bomber's performance objectives. Originally conceived as a high-altitude bomber, the Air Force requested low-level strike capability to increase the B-2's chances of survival. It meant that large portions of the bomber had to be entirely redesigned, including repositioning control surfaces to compensate for the stresses of high-speed, low-altitude flight. The redesign delayed the bomber by 2 years and added $1 billion more to the program's cost. And as development dragged on, relations between the United States and the Soviet Union took an unexpected turn.
You repeat that at every meeting.
In 1985, the Soviet Union got a new leader who was much more open to friendly relations with the United States. The threat of nuclear war dissipated. Not only that, few realized it at the time, but the Soviet Union itself was about to disappear. By the time the B-2 was unveiled to the public in 1988, the bomber's very reason for existing was called into question. This was the most expensive aircraft ever produced, with a production budget that had spiraled out of control. In 1988, each B-2 was estimated to cost $500 million, and that number would grow to a staggering $2 billion by the time the aircraft entered service. By the late 1980s and early 90s, Congress had the bomber in their crosshairs, arguing that it was too expensive to justify and no longer necessary.
With its mission in doubt, further expenditures on the B-2 cannot be justified.
With respect to the B-2, do we need it? Can we afford it?
After $20 billion for research and 10 years to do it, the contractor and the Pentagon got excited because it went down the runway and stayed in the air.
But the military-industrial complex argued that the B-2's extraordinary capabilities justified the extraordinary price.
With the range of this aircraft, with a payload, 50,000 pounds worth of payload, can take off from the United States and with one refueling go 10,000 miles. There won't be any place in the world that the United States won't be able to project force, if needed, during times of problems in the Middle East, in Africa, in Central America, or any place else in the world.
But with enormous public pressure to rein in costs, and with Cold War relations continuing to improve, B-2 production was dramatically scaled back in 1990 from 132 to 75. And when the Soviet Union ceased to exist just a year later, that number was further cut down to just 20 bombers. Judged by its enormous costs or its limited production run, the B-2 is controversial. But those numbers don't tell a complete story. From an engineering perspective, the B-2 is one of the most impressive aviation projects in history. And from a strategic perspective, the bomber stands on its own. With the collapse of the Soviet Union, the B-2's nuclear deterrence mission was largely replaced by its unmatched ability to deliver conventional precision strikes in contested airspace. B-2s first saw action over Kosovo in 1997, utilizing their impressive payload and range to complete 30-hour-long missions all the way from the United States. Despite operating amongst hundreds of other NATO aircraft, just 6 B-2s struck more than a tenth of all targets during the war. The bomber also played a vital role in subsequent conflicts, engaging the most heavily protected targets. More recently, B-2s were used to destroy ISIS training camps, leading some to question whether such a sophisticated and expensive aircraft was really needed for the mission. But aside from its ability to field a greater number of guided weapons, the B-2 has always had a powerful psychological impact. Because no corner of the world is safe from the sinister-looking machine that can suddenly emerge without warning. But 30 years on, the B-2 is no longer at the cutting edge of stealth technology. And since 2015, the United States has been developing a next-generation stealth bomber to replace the B-2. First unveiled to the public in December of 2022, the new bomber will be designated as the B-21 Raider. And beyond employing the latest stealth technologies, the Raider promises to be far more economical to build and operate. suggesting that the new bomber could be built in larger numbers, eventually replacing not just the B-2, but the B-52 and B-1 as America's new frontline bomber. Until then, the B-2 will continue to serve as the tip of the spear for at least another decade. Because even as the F-117 has long been retired, the legendary B-2 continues to prove itself well into the 21st century.